All right, good morning again, grade 11s. Now let's just summarize what, I hope you watched the other video I made today. It's about 10 minutes long, just explaining using the demonstration about series and parallel circuits, okay, using the circuit simulator. Okay, so now let's take a look at that and just what that means in terms of doing the math. Okay, so look, here, I'm going to call this, whoops, let's change that to something I can write in. Let's call this VB, voltage in the battery. And we're going to call this V1, V2, and V3. So here, let me zoom in and do it a little nicer than that. Voltage in the battery. Okay, V1, V2, and V3. And we're going to call this current I. Okay. Now, the current going into, we'll call this IB coming out of the battery. This is, we'll call it I1 here. This is I2 here and I3 here. Okay. So if that makes sense to you, this is flow through the pipe, okay, through the wire, and that's it. Okay, now according to Kirchhoff's laws with a series circuit, and according to what we've seen in the demonstration, we know, okay, that I1 equals I2 equals, since there's only one path, all the currents are the same number. They're all equal to the battery, so we might as well just call it I. Okay, so instead of calling them I1, I2, I3 like they're all different numbers, okay, we'll just call it I. Now this is according to the current law. So since there's only one path, current has to be the same everywhere. Now for the voltage in the battery adds up. Okay, so in a series circuit, the voltages add up and the currents are all the same. Okay, now I'm going to use Ohm's law. So Ohm's law tells us that V equals IR. So therefore, I'm going to replace VB with I times the total resistance, okay, in the circuit, equals, and then V1, I'm going to replace with I1 times R1. In fact, I'm just going to, here, let me do it like this. I times R1 plus I times R2 plus I times R3. Now, what I've done is I've taken this equation and replaced all the voltages with I times R. Okay? So, all the I's are the same. So since they're all the same number, I can cancel them out. Okay, so it's a common factor. And I get something that is really obvious to everybody probably, that the total resistance in a series circuit would just be the sum of the individual resistances. And if I had 4 or 5 resistors, this pattern would continue, right? So I'm just going to put plus dot dot dot. Okay? And then I'm going to do an example for you. Okay, let's say R1 was equal to 5 ohms. Let's say R2 was 10 ohms. And let's say R3 was 15 ohms. Whoops. Like this. Then what is the total here? I'm going to put this in a box. What's the total resistance? I don't mean to insult your intelligence here. Some students will say, whoa, the total. Well, obviously the total is just 5 plus 10 plus 15, and that is equal to 30 ohms, right? And you'd be right. That's it in a series circuit, okay? Now I could give you some more data. I could tell you, all right, what if the voltage in the battery was equal to 45 volts, okay? All right, so if that's the case, then what is I? Okay, so what is the current equal to? Well, you just use Ohm's law, where the voltage in the battery is the I times the total resistance, okay? So V is equal to IR. So therefore, I would equal the voltage in the battery divided by the total resistance, which is equal to 45 divided by 30, and that is 1.5 amps. Okay? So now that I've asked you those questions, let me ask you this. What's V1, what's V2, and what's V3? What are the three voltage drops in those three resistors? Well, V1 will be I1 times R1. Whoops. Times R1, which is equal to 1.5, because all the currents are the same, times 5. Okay? And 1.5 times 5 is 7.5 volts. Okay, now what's V2? Well, it would be I2 times R2. So that's 1.5 times 10. That's 15 volts. That one's easy. Okay, and V3 would be I3 times R3. It's Ohm's law, right? Well, that's 1.5 times 15. And what is that, 22.5? 1.5 times 15. Yeah, is 22.5 volts. Okay, now if you add all these three numbers up together, what do you get? Well, you're going to get 45. Now, we knew that would happen because that's Kirchhoff's voltage law, right? We know the voltages have to add up, but you see it works out. It all works out. So what we've just done is we've answered a question like this. What if I gave you three devices that had these three different resistances here, and I asked you to connect them to a 45 volt power source? Well, you just figured out, I just figured out for you, how much voltage each one would get and how much current each one would get. And you see, when you're working with electrical circuits, these are very important questions to be able to answer. All right, so that is the series circuit, and there's an example of the series circuit. Well, now let's look at the parallel circuit. Okay, so here's our parallel circuit, and again, what I'm going to do is I'm going to say that this is the voltage in the battery. We're going to call, here, let's use conventional current. This is the current in the battery. This is I1, I2, and I3, and remember they do not have to be the same in a parallel circuit. Okay, these are all junctions, so like there should be a little, oh no, that one's not a junction. Junctions here, okay? So, and we'll call this V1, okay, here. I'll just write it on this side, V2, and V3 over here. I guess I'll be consistent, I'll just write it here. So that's how much voltage each one drops. Okay, now we know from Kirchhoff that the voltages, and we saw in our demonstration, the voltages are all the same. So we might as well stop calling them different things. We might as well just say that they're all V. Okay, so there's only one voltage, whatever the battery is set to, okay, in this circuit. Now we know the current, though, adds up. And that makes sense according to Kirchhoff's current law. Okay, so we have these junctions here. The current flowing in, which comes from the battery, must equal the current flowing out. Well, there's three paths coming out, and so those three, they have to add up to give us the total current. Okay, so I'm going to use Ohm's law. So it's the same as I did before. So this time I'm going to solve it for current. I equals V over R. Okay, so therefore, taking this equation and rewriting it, VB over R total, the total resistance, would equal V1 over R1 plus V2 over R2 plus V3 over R3. Remember, all the voltages are the same, and therefore, pardon me, therefore they all cancel. And you end up with, when they cancel, you don't get 0, remember, you get 1. So you're going to get a number 1 over all of these things, and therefore 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. And if there were more paths, that pattern would continue. All right, so just like before, I'm going to put this equation in a box. This is how you calculate total resistance in parallel. That's very different from what we found in series. It's not as intuitive, right? They don't just add up. So let's do our example. Let's say we have a parallel circuit, same as before. Everything's the same. R1 is 5 ohms. R2 is 10 ohms. R3 is 15 ohms. 15 ohm. Having a hard time. Okay, is 15 ohms. And then let's say the voltage in the battery is set to 45 volts, like I did before. Okay, first, let's find the total resistance. So you're going to 1 over RT equals 1 over 5 plus 1 over 10 plus 1 over 15. Now, what's the total? Well, the thing is please don't say it's 1, okay, let's get the math straight here. The answer is not 1 over 30, okay? That fractions don't work that way. There's a button on your calculator. Okay, my button on my calculator looks like that. It could look like this on some of your calculators, the reciprocal button I call it. So since these numbers are all reciprocals, they're all 1 over something, then I'm just going to use that button on my calculator, okay? And so what I would do, I'm just going to say it, but use the button on your calculator is very useful. I'm going to press 5, and then I'm going to press 1 over x plus 10, and then I press 1 over x again, and then I go plus 15, and I go 1 over x again, and I press equals. Okay, and when I do that, I get 1 over RT equals 0.3666, repeating, whatever. Okay, now that's not my answer, that's 1 over my answer. So I'm going to press 1 over x one more time, and I find that the total resistance is actually 2.72, and it repeats after that. So I'm just going to round it to 2 decimal places, approximately 2.73 ohms. Okay, now look at that number. See how small it is? It's actually smaller than the smallest resistance. So here's the weird thing about a parallel circuit. The more resistors you have in parallel, the lower the resistance. So if you start with just a 5 ohm resistor, and then we add a 10 ohm in parallel, it actually lowers the resistance. It makes it lower, which makes sense because you're adding paths, and the more paths you have, the lower the total resistance is. Okay? So anyway, that actually makes sense. So here's the deal. Let's finish this problem. Can we find all the voltages and all the individual currents? Well, first I want to find the total current. So that's IB, current coming out of the battery. IB would equal the voltage in the battery using Ohm's law divided by the total resistance. So that's going to equal 45 divided by I'll just do it. I get 16.5. I didn't do any rounding, but I got 16.5 without the rounding. So that's amps. All right, now, what about finding the individual currents and voltages? Well, let's do that right now. So we know that V1 and V2 and V3 are all equal to the battery. So that's 45 volts. So that's no problem. Okay. But what about the currents? Well, we know that I1 would be V1 divided by R1. Well, this is 45 divided by 5. Well, that's just 9 amps. Okay. I2 would equal 45 divided by R2, which is divided by 10, which is 4.5 amps. Okay. And finally, I3 would equal 45 divided by 15. Well, that's just 3 amps. Okay. Yeah, that's 3 amps. Okay, so now when I add them all together, I1 plus I2 plus I3, what does that add up to? Well, it adds up to 16.5 amps. And we know that that's right because that's what we got when we did it this way. And see, so it all works out. Okay, now this is slightly harder. The parallel example is slightly harder than the series one. The series one is very straightforward. Everyone usually gets that. Okay, but I will tell you that I did both of these things in grade 9. Okay, series and parallel circuits. You won't have, I don't think, any problem with it if you work at it. Okay, and do the homework. Okay. Now, I told you at the beginning of this video, or one of the videos anyway, I think that in the demonstration, that this was a difficult, there's some difficult problems here. So let me show you what happens when you have a combination of these two things in one circuit. So that's called a series parallel circuit. I did not do this in grade 9. Oops. A series parallel. All right. So how do you solve problems that are called series parallel circuit problems? Okay, so if you look, these two things here are in series, but these two are in parallel, and they're all connected together in the same circuit. Okay, so how would you solve a question like this? Like if you're asked to fill in the missing voltages and currents and everything else. Well, what you would have to do is follow the following method. 1, identify the parallel part of the circuit. Okay, now 2. Is there more than one resistor on the individual paths? You have to answer this question, okay? And then I'm going to say, if the answer to that question is yes, add them. In series. Okay. On each branch. And if the answer is no, you just proceed to step 3. Okay, now step 3. Use 1 over RT equals 1 over R1 plus 1 over R2 plus, and so on, to find RT, okay, the total resistance for the parallel part. And then after that, step 4 is the final step. Sorry, it's lagging for some reason. Okay, number 4. Add the remaining resistors in series to get the total for the circuit is R1 plus R2 plus R3 plus, and so on. Okay, so that's how you find the total resistance, okay, in a series parallel circuit, and that's actually the first step in solving the circuit. So let me show you an example. Let's look at this one. Okay, and I'm going to put in some values here. Let's say this one's 5. Let's say this one's 10. Let's say this one is 15 like before. Doesn't have to be these numbers, by the way, I'm just making it up. Totally arbitrary on my part. And let's say R4 here is 20. Okay, so I'm just going up by 5, so it really doesn't make any difference. I'm totally inventing these numbers. Now let's say the battery here will make it, I'll just write the voltage. Let's say it's 50 volts. Like in my demonstration, I made it 50 volts. All right, so you got 50 volts connected to this collection of resistors or loads. Okay, now the question is, can you find all the missing values, all the missing voltages, all the missing currents, and so on? Now the first step, okay, is finding I1 here, or IB, the current coming out of the battery. And to do that, we need the total resistance, okay? So you find RT using those steps, okay? So let's go ahead and do that. Okay, so look, I've circled the parallel part. So I already did step 1 down here. Identify the parallel part of the circuit. So I did that. Check. Is there more than one resistor on the individual paths? No, because each path here, here's our split point, each path only has one resistor on it, right? So only in the parallel part, that's all I'm looking at for now. Okay, so the answer is no, so I proceed to step 3. Step 3 is just looking at this part here. So this is step 3. I'm going to go 1 over RT equals 1 over 15 plus 1 over 20. Okay, so that means that the resistance for just that part, remember, I'm going to use my calculator, 15, I'm not going to bother with common denominator and all that, forget that stuff, okay? And I'm going to find the total resistance. I get 8.57 ohms. So this, I'm going to store that number in memory. I get 8.57 ohms. So now I am at step 4, like I just used step 3, okay? Now I'm at step 4, I'm going to just add whatever's left. So this is what's left, my 2 resistors that were in series that I've so far ignored. So therefore, the total for the circuit, this is the total just for this part. The actual total for the whole circuit will equal 8.57 plus these 2 things that are in series, the 5 plus 10. Okay? So 8.57 plus 15 basically, and I get 23.57. And that, I'm going to store that number in memory. That is the total resistance. So what I've done to solve the question is I found the total resistance and I got 23.57 ohms. Now I'm going to find the total current, IB. I use Ohm's law, so it's VB over the total resistance. Okay, so that's going to be 1 over that times 50 volts. So that's 50 divided by 23.57. That is equal to 2.12 amps. Okay, now is where you have to use a little bit of cleverness, okay? So you look at your circuit, okay, and we found that, I don't know why it's so laggy, but anyway, we found that this current here is 2.12 amps, right? Now if you follow that path, that has to be I1 going through that first resistor because there's only one place for it to go. It also has to be I2 going into the second resistor because, again, it's the same single path. So I1 and I2, we just found out what they are. We just found that I1 equals I2 equals 2.12 amps. Now, what we're going to do now is, now that we found, this is now step 3, now we have to sort of go around the circuit and fill in all the missing values. So I might as well do V1 now. V1 will be I1 times R1 using Ohm's law. Okay, so that's going to be 2.12 times 5, right, for my first resistor. So times 5, I get 10.61 volts. Okay, now V2 will equal I2 times R2. So that's equal to times 10, 21 point, should be 21.2 of course. So that equals 21.2 volts. Okay. Now, what I want to do is I'm going to total these two things. I need to do that because I need to figure out how much voltage is left for the other two guides. Okay. So I got 21.2 plus 10.6 is 31.81. So I get here the total is 31.81 volts, and therefore the remaining voltage, okay, will equal what's left over for V3 and V4. So it's going to be 50 minus 31.81. I'll show you why that's true in a second just by looking at the picture. So negative plus 50, I get 18.19 volts. Okay, so why, I'm not quite done yet. I have to find just the two missing currents. But like, look, think of it like this. What we found was that the voltages dropped by these two resistors here adds up to like whatever it was, 30.19, right? So like if you look at my little picture here, I get 31.81 volts is the total there. So when you go back to your circuit, okay, then you only have one resistor left because there's a fork in the road. So some of you are going to go this way, some of you are going to go this way. So the remaining voltage, okay, is whatever's left after you've gone through these first two. Okay, so you have to use Kirchhoff's laws. I told you it's kind of hard, these questions. So what you do is we subtracted to find that. So now that we found those two missing voltages, now what we're going to do is find the two missing currents. So I3 will equal V3 over R3, okay, which is equal to 18.19 divided by 15. And I4 will equal V4 divided by R4, which is equal to 18.19 divided by 20. Okay, so when I do that, I get 1.21 amps here, and over here I get 0.91. And when I add those two things together, I get 2.12 amps, which is what I should get. Okay. So what I've done in this question is I found a whole bunch of missing values. So what I've essentially done is said, listen, if you connect these four loads to that power supply, okay, which is what's important when you're designing a circuit, this is what will happen. This is how much voltage, this is how much current each device will get. And that is what you do in a series parallel circuit. Now, it's one of the hardest things we do, okay? In fact, I don't think there's anything harder than this in the whole rest of the unit. It's sort of the one hard problem you have to sort out. But that's it, okay? Now, here's another example for you. So I'm going to do this one for you also, okay? So first, we find the total resistance using these four steps, okay? So first we need to identify the parallel part. So I'm going to take out my highlighter, or my rainbow color, and I'm going to circle it right there. I recognize that immediately as the parallel part. Step 2, okay, just using these steps, is there more than one resistor on the individual path? And the answer is no. See, like what that means is if there was another resistor here, let's say, then that would be like the fourth resistor or whatever. Then there's two resistors on this path. I would need to add those together in series first before I go to step 3. But that's not the case, so you don't have to worry about that. So we've done step 2, so now step 3, we find the total resistance of this section here. It's not for the whole circuit, so it's 1 over RT will equal 1 over 20 plus 1 over 30. Okay, I take out my calculator and I need to find that total resistance, so I go 20 plus 30. I get, long story short, I get RT is 12 ohms, okay? So now we've found the total resistance here. This, what I've circled, is 12 ohms. So now I add that in series. Okay, so now I'm on step 4, add the remaining resistors in series. So it's going to be, I replace what I've circled with 12, so it's 38 plus 12 is 50 ohms. Okay, so I get the resistance for the whole circuit would be 12 plus 38, which is 50 ohms. Okay, all right, so now I've done that. Okay, step 2, find the total current by going the voltage in the battery divided by the total resistance. That's Ohm's law. Okay, so what's the voltage in the battery? It's 25. So it's going to be 25 divided by 50 is 0.5 amps. Okay, all right, now you have to think about this. This is how much, okay, forget this letter E. This is how much current, that's I1, going through that first resistor, because if I get 0.5 amps coming out there, okay, and then 0.5 amps comes back to it, well, that everybody has to go through that first resistor before you get to this fork in the road, right? And so what's happening is R1 and I1 has to be 0.5. So now, step 3, I'm going to find all the remaining missing values. So I'm going to say, okay, I recognize right away that I1 equals 0.5 amps. Just by looking at the circuit, you recognize that. So therefore, V1 will equal I1 times R1. And so it's going to be 0.5 times 38. And 0.5 times 38 is what, 19? So it's going to be 19 volts. Okay? All right. Now, since this one is 19 volts, now that means, using Kirchhoff's laws, that I have a total of 25 volts. Well, if I take either one of these other paths, I have to lose the rest of the voltage. So that means V1 and V2 have to be 6 volts each, because if you take the path on the right, for example, okay, with the third resistor here, this one, if you take this path, you have to lose the rest of the voltage from the 25 volts, okay? So what I'm saying is that V2 equals V3 equals 25 minus 19, which is 6 volts each, okay? So you get 6 volts each. Now just find the missing currents. So I2, pardon me, will equal V2 over R2, which is equal to 6 over 20. What was that, 0.3? 6 divided by 20, yeah, 0.3 amps. And I3 will equal V3 over R3, which is equal to 6 over 30. And 6 over 30 is 0.2 amps. Okay? And just so you notice, these two things add up to give me the 0.5 amps, which makes sense, okay? Like, it needs to be consistent, because the 0.5 amps has to go back to the power supply, right? All right, so that's the end of this question, these filling in all the missing values. So, look, I took this video took 30 minutes to record, 34 minutes. It's a tough topic to breach. It's a hard one, you know, so what I'll ask you to do now is try doing the rest of this homework that we haven't done yet, and you'll have the rest of the week to do it. We're done after today's lesson. We're done the electricity unit, the electricity portion of the unit, and we talk about magnetism. So let's just show you where we are. I want you to finish this now. Okay. So if you look at where we're at in the homework on circuits, I'm just highlighting in yellow what we've been doing with circuits. We've done all this, okay? So we've actually talked about electrical power already. So you should be in a position now to finish everything up to this rainbow line, okay? And then magnetism and magnetic fields will be a complete break from circuits. It's electromagnetism, so we're not done with circuits yet. But yeah, and then we're going to have a quiz next week on everything up to here. Okay, so that's it for this week, guys. I think we should have extra help maybe on Monday if you have any other questions about it, or if you want to do another one. Like, there are 3 questions in the homework. I forget what page they're on. I think it's on page 459, but take a look at it, do it. It's a numbers game, right? Doing the series parallel circuits. But the ones I showed you are as hard as they get. Okay, so that's it for today. Try to complete the homework. I do have another worksheet if someone wants more practice, and we'll have a practice quiz and everything else that I'll post later, but it's no new lessons this week. And then maybe Monday we'll have extra help, and then Tuesday quiz, okay, for next week. And we'll start magnetism next week too. The quiz is actually not 3 hours long, so it'll only take maybe an hour or so. It's 2 pages. They had a half hour to do it when last semester because we did a lab test, which you won't be doing this year. So, okay, so that's it, guys. Have a good day. We'll talk to you soon.